stop! Before you scroll past this, I need you to hear one thing. There is a star in our galaxy that scientists have been staring at for over 10 years. A star that dims in ways that break every rule of physics. A star that has been getting darker for over a century. Every explanation they've tried failed. Comets? Dust? Doesn't fit. A planetary collision? Doesn't fit. And then one scientist said the words nobody wanted to say out loud. What if it's not natural? This is Tabby's star. And by the end of this video, you're going to understand why it might be the most important object in the sky, or the most terrifying. NASA's Kepler telescope had one job: find planets. When a planet passes in front of a star, the star gets slightly dimmer, just 1%. That's how we find worlds. Jupiter, the largest planet in our solar system, only blocks 1%. Kepler had found thousands of planets this way. Everything was going exactly as expected. And then it looked at KIC 8462852. The star was dimming by 22%. That's not a planet. Whatever was in front of this star was not a planet. It was something else, something that had no right to be there. Kepler had observed 150,000 stars. It had never seen anything like this. Not once. Something massive. Something the size of a world or bigger. And nobody knew what it was. Here's the twist you didn't see coming. This wasn't found by a NASA scientist. It wasn't found by a supercomputer. It was found by a group of ordinary people sitting at home, clicking through star data on their laptops as volunteers. The Planet Hunters Project lets anyone on the internet help search for anomalies in Kepler data. And a group of citizen scientists, led by a scientist named Tabitha Boyajian, flagged this star and refused to let it go. That's why it's called Tabby's star, an amateur discovery that became the biggest astronomical mystery of the century. Think about that. The most puzzling object in the known universe was found by people exactly like you. And then astronomers went looking through old photographic records, telescope plates from the 1890s, over 100 years ago. They found something that changed everything. Tabby's star was brighter back then, significantly brighter. It had been slowly, steadily fading for over a century. Not just occasional dips, a long, slow, unstoppable fade. Whatever was happening, it didn't start with Kepler. It had been happening long before any of us were born. Something had been dimming this star for over 100 years. What could possibly do that? Scientists grabbed the most comfortable explanation first. Comets. A massive swarm of comets passing in front of the star, that would create irregular dimming. It sounds reasonable, it sounds safe, except the math doesn't work. To block 22% of this star's light, you'd need so many comets that they'd outnumber every comet ever observed in every solar system we've ever studied combined. The numbers are simply impossible. So scientists took a breath, crossed off comets, and moved on. What about dust clouds drifting between us and the star? Dust absorbs starlight gradually. That could explain the century-long fading. It felt promising. But here's the problem. Dust doesn't block all colors of light equally. Red light bleeds through. Blue gets absorbed more. You'd see a color shift. Tabby's star shows no color shift. All wavelengths dim equally. That means whatever is blocking the light is opaque, solid, large enough to cast a complete shadow. Not dust, something solid, something real. Two planets colliding, shattering into trillions of pieces. That debris spread across the star's face, creating chaotic, irregular dimming. Honestly, that one felt exciting. It fit the pattern. Finally, something that made sense. Until they checked the heat. A planetary collision creates enormous infrared heat. Fresh debris glows. But Tabby's star shows no excess heat signature. None. Which means either the collision was millions of years old, but then the debris would have spread and disappeared by now, or the collision never happened. In 1960, before any of this, a physicist named Freeman Dyson asked a question. If a civilization gets advanced enough, really advanced, they're going to need more energy than their planet can provide. So what do? They go to the source. They build something around their star, a massive structure or thousands of structures to capture the star's energy directly. A Dyson sphere, or a Dyson swarm. From Earth, a Dyson swarm would look exactly like a star that dims irregularly by massive amounts with no clear pattern. Exactly like Tabby's star. And here's the part that should make you uncomfortable. A civilization advanced enough to build a Dyson swarm wouldn't waste energy as heat. They'd use it all, so there would be no infrared excess. Exactly like Tabby's star. Every single data point fits. Scientists didn't want to say it, but the physics forced them to. SETI, the organization that searches for alien intelligence, pointed their most powerful radio telescopes directly at Tabby's star. They listened for months. Radio signals, laser pulses, any pattern that couldn't be natural, and they heard nothing. Silence. But before you feel relieved about this, we've only been broadcasting radio signals for about 100 years. In cosmic terms, that's yesterday. A civilization thousands of years more advanced than us might not use radio at all, the same way you don't send telegrams anymore. We were listening for the wrong thing. Silence doesn't mean nobody's home. Remember what I said at the beginning? By the end of this video, you're going to understand why this might be the most important object in the sky, or the most terrifying. Here's what I didn't tell you then. The most terrifying possibility isn't that it's an alien megastructure. The most terrifying possibility is that it is, and they finished building it. A civilization that has completely harnessed their star's energy, that has moved beyond radio signals and lasers and everything we know how to detect. A civilization so advanced, we can't even recognize their engineering as engineering. We see it as a mystery. They see it as Tuesday. Tonight, go outside. Look toward the constellation Cygnus. Somewhere in that direction, 1,480 light years away, a star is dimming in ways we cannot explain. It's been doing it for over 100 years. It will keep doing it long after you're gone. We just have to keep watching, because something out there might already be watching back.